Hi, this is Stace from Varnish Software, and today we're doing a joint webinar with the lovely people of CacheFly, and I have the CTO and the founder of CacheFly right here with me, Mr. Matt Levine. Hi, Matt. How are you doing?
Good, Des. How are you?
I'm great.
So my name's Matt Levine. I'm the CTO and founder at CacheFly. We were founded in 2002, so we've been doing the CDN thing a little while now. And, we help our customers entertain the world is kind of our tagline. So also a little education, also help some people do some business. But, fundamentally, we're here to make the internet deliver a better experience for users.
You're built on top of Varnish, am I right?
We are. Our caching layer, we moved to Varnish in, I want to say it was 2013. And prior to that, we'd had a homegrown, open source based 10,000 patches away from mainline solution to get our caching solution where we wanted it. And we moved to Varnish, specifically Varnish Software's build to Varnish, the supported version, originally for MSE. So our big challenge originally with Varnish open source was with the size and variety in our object catalog. The file backend just wasn't cutting it for us. So originally we moved for MSE, and I think at last count we might be using 8 or 9 of the vmods now. So it's we're trying to leverage everything we can to deliver the best experience for our customers.
Yeah, and that's something that I hear a lot at Varnish Software, and especially with the clients who build CDNs and video platforms on top of it, is that MSE is like the main feature they use. MSE, for those of you who don't know, is short for Massive Storage Engine, and it's a custom storage engine, or a stevedore as we call it internally, that does a best of both worlds between optimizing memory consumption, use of memory, but also having a persistence and disk layer so that you can store like terabytes of data on a single server. So for someone like you who operates and runs like a major CDN, that's like a big part of it.
Yeah, and we were happy with MSE, the last version, already. It was already such a win for other reasons. But this has actually eliminated our biggest engineering challenge. And it was something we started talking about probably 4 years ago. And the team did a great job, again, totally making effectively a new version of MSE that was decoupled from just using the page cache for file caching. And I would say from a caching standpoint, from the 20, if it's 2080, from the 20%, that's probably been the single biggest win operationally for us in the last 6 or 7 years. Has been, the engineers get to breathe a sigh of relief about like, oh my God, what's the kernel going to do this week to our memory? So it's been the most transformational thing from our standpoint in our relationship with Varnish Software over the last 7 or 8 years. But not to take away from all the vmods and all the other features that we use. Yeah. But at the end of the day, features aren't useful if it doesn't scale.
No, but your 20% is our 80%, and that's one of the key. That's like a good summarizing point for this topic is like there's always specialists. You specialize in specific types of CDNs. There's so many incarnations of CDNs. There's so many brands. There's so many flavors. You specify or you specialize in one thing. We have a specialization. We depend on libraries that were written by other people to keep it up, to make sure that it's not exactly a house of cards, so to speak, but that the structure is there.
Yeah.
But what I do want to talk about is multi-CDN, because we've touched on it a number of times. You talked about that the APIs aren't always there. Like, I'm going to start approaching this from a commercial point of view. You are a CDN vendor, a pretty big one. I think we got a report earlier this week, sort of rating that you were number 2. Like in a list, I could send you the link. There was like
definitely not in terms of traffic, but maybe in terms.
No, I'm talking traffic. But like, there's so many measurements. I think it was also in terms of quality. I saw a list and you were number 2. So what would be the logical decision from a commercial point of view is drive all that traffic to you. So enlighten me on multi-CDN. Why would you send traffic to other CDNs knowingly? How does that work?
Sure. So we like multi-CDN for a few different ways. So from our commercial standpoint, the reason we like it is just what you said, which is that we're usually pretty good at performing. And multi-CDN at its core, whether it's via test files or whether it's via the API or whatever it is, it's a bit of a meritocracy. So there's no, you don't need to listen to who says they're fast. You don't make decisions based on anybody's marketing or how much the sales team convinced you they were fast. The numbers speak for themselves. So from our standpoint, our best way to approach a customer is somebody who's already doing multi-CDN and say, put us in, don't commit any traffic to us, and make sure it's on performance mode. Give bits to whatever CDN is fastest. I'm not gonna tell you that we're better. I'm not gonna send you that report. I'm not gonna do it. Just put it on. If I'm lying to you, I'll get no traffic. Your multi-CDN thing will say, oh, they're not that fast. And so that's our biggest advantage that we see in the market as somebody who is likely to gain more traffic from multi-CDN than lose it. I think it's very different if you were selling on reputation or somebody did a deal with you because of good marketing.
Well, that happens as well, of course. Like if you're already in the multi-CDN business, you have a way of measuring these things, and then indeed the numbers speak for themselves. But like your average company looking to outsource like web acceleration, they're just going to look for what's out there with has good pricing, which has a good reputation. There's some names in there that people like.
and that's okay. There's nothing wrong with that. I think the multi-CDN today has some pretty specific use cases. So everything is a trade-off of complexity, management, cost. So the first thing to keep in mind, multi-CDN isn't free. And in many cases, I know some customers who pay more to their multi-CDN vendor to balance between the CDNs than all of their CDN bills combined. So it's not.
But do you provide these services? Because because you can be thrown in the mix in a multi-CDN, but do you provide like multi-CDN services yourself?
If somebody comes to us looking for implementation help, we will introduce them to partners. So we pretty much work with everybody that's doing multi-CDN, and we're happy to help people on a consulting basis, but I prefer, if I'm involved in the engagement, I try and be as arm's length as possible. I don't like the idea of being the fox in the hen house. It makes me physically uncomfortable to have a customer say, hey, can you configure our multi-CDN for us? And I'm like, I have a vested interest in how this goes. Like, why don't you have, and I also, it would be one thing if when we turned it on, we were like 8%. But I know from experience, we're pretty good at performing. So when we turn it on, it's going to be 30%, even in like a 4 or 5 CDN mix, might even be higher. And then you're going to look at me and go, did you really configure it fairly? Or what did you put in there? So,
but that's always, there's a trade-off, right, Matt? So performance is your strong suit.
Yep.
Like, I won't put you in the spot where you have to talk about weaknesses. It's not really a weakness, but there's always a trade-off, right? So there's things you focus less on. What would that be in your case in regards to multi-CDN?
Well, in regards to multi-CDN, I think there's not really, I don't think we have a trade-off there. And the reason I say that is where we would normally be in a position where I would say we can't do a good job with you as somebody else is more the wraparound services. So what we do, we focus really hard on delivering a great HTTP experience. We push bits over HTTP, which is great for people looking for somebody to push bits over HTTP. When you're looking for a complete video solution that's going to give you analytics and a player and all those things, we sometimes serve those companies or we partner with those companies or we're in their CDN mix, but we don't provide that same wraparound experience that some other CDNs do. So if you're looking for some pretty specific, almost professional service level type engagements, we don't really do those things. But with multi-CDN, by the nature of it, you already can't use that with everybody, and you're reduced to the lowest common denominator of feature sets.
I was about to use that term as well, because like some company A has that feature, company B might have the same feature but implemented differently with a different API. So it's like you have to indeed use the common denominator, and that's just what you said, just sending HTTP requests and making sure they come through fast. So you're right there.
And where we do help people that are just getting into it, because of Varnish and the other parts of our software stack, we're very flexible in what we do. So we have some people that are just trying to dip their toes into multi-CDN. They're using somebody else today, and let's say they use token auth for their video segments. We just implement our competitors' token auth on our servers, so they can use the same signed URLs with either CDN. So that's one way we help people. We're also pretty experienced doing multi-CDN. So when we, once in a while, we'll field a support request that is for a multi-CDN customer, and it's clearly not us. They're clearly sending some, or a better example is an incompatibility. So we've caught examples for people where they say, hey, this is broken, we don't know why. And we'll dig into it and we'll go, actually, you have 4 CDNs in your multi-CDN setup. CDN 3 is serving a different E tag for this object than the other 3. And that's why you're seeing this behavior. Or that one's actually serving gzipped encoding when everybody else is serving the plain text. So when you go to 304 that, you're going to run into problems. So I think it's helpful that we have experience. We've been doing it a long time. We partnered with some of the earliest multi-CDN vendors. But it used to be a thing where you tried a CDN and they failed you in some way. So then you moved, and then they failed you in some way. And then you looked for somebody else, and then you were happy for a while, and then you weren't happy anymore. And then after 4 or 5 CDN attempts, you ended up on multi-CDN. There is nobody.
Your use case supports it, because like it's a bit of overkill. This is not like multi-CDN is not for everybody. It's like for people who are very sensitive to traffic spikes, who probably want low latency, who might be all over the world and are looking for the fastest way to go from point A to point B.
Yeah, and today I think the only clear-cut example, there is nobody who has launched a consumer-facing video service of any scale in the last 5 years who does not use multi-CDN, including those people launching video services who have their own CDN. So large cloud player that's also a big retail player that also has a video streaming service does not just use their cloud CDN to deliver their video. For the reason that even if you're number 1 or number 2, what that means is across all of the prefixes in, let's say, the Philippines, your average speed is the best. But you might be worst. You might be worst to 4 of them. And somebody else might be best to those 4. And what multi-CDN allows you to do is put all the CDNs in the best possible scenario to succeed. And that's the other hidden benefit on the commercial side if you're a CDN. Let's say you know that you're full to somebody. And that person that you're full to is really hard to get upgrades with, and they're a pain to deal with, typically a nationalized telecom. And in a pre-multi-CDN world, your customers are going, hey, you're slow today to this place. We're getting complaints from this place. This is really bad. In multi-CDN, it goes away. They're like, oh, you're worse than this other CDN. It's going to go to there. So you still have to fix it. And then hopefully once you fix it, you're rewarded with revenue. So you have a profit incentive to make the network better. But at the same time, if something is broken, you have to do less scrambling for multi-CDN customers because it's already been shifted. So it allows you to move away from big capacity problems on the CDN side. But on the client side, you only get to see everybody's best effort. And
you're relying on HTTP best practices because like you're talking about bits over the network, but it all comes down at the layer 7 to HTTP and all the best practices that HTTP has and all the mechanisms for caching that we're obviously leveraging, not just CacheFly, not just Varnish, but everyone who is in the content delivery space who does something with HTTP. Like there's like a lot of people underestimate how powerful HTTP is to get that job done. And in this changing environment that we live in, like we're seeing that although the interface and the API of how we communicate request response base remains mostly the same, like what is under the hood is constantly changing. Like we've been using HTTP 1.1 for a super long time. All of a sudden, we got HTTP 2 because we realize all of a sudden that like one request per connection doesn't really cut it in a sequential way. We need to parallelize it, and then we go full duplex. And all of a sudden we notice that TCP is a bit bothersome when doing that. And like Google invented Quick. Quick is the basis of HTTP 3, whereas also HTTP 2 was based on Speedy. So all these industry things are changing, whereas the way we're communicating very much stays the same. Like a cache control header is still a cache control header. And although there might be some implementation differences, vendor to vendor, and some like opinions that people have on how they should behave in regards to specific things. Let's say to cache control as max-h versus max-h, public versus private, must revalidate, stale while revalidate. All these things are inside the headers. Like it is a matter of reading the spec, applying it, and that's the common denominator we're talking about, right? HTTP and the possibility of HTTP to cache data using all those best practices.
Yeah, and you look at it took somebody the scale of Google to move some things forward, but even then, where HTTP is deceptively simple, TCP is deceptively simple, TCP/IP is deceptively simple. The challenge is that if you could force an upgrade on everybody, it would all be easy. And that's the interesting thing about the internet today. And SSL would probably be or TLS would be the only area that we're willing to give up backwards compatibility for. In the name of security, but we're always limited by the same basic constructs. So HTTP can't go faster than the underlying transport protocol. So Google said, okay, let's change the underlying transport protocol. But they couldn't say, let's make a new one. Nope. So they said, okay, well, we have to use UDP. And what can we build on top of UDP? And in the end, Quick is you're just reinventing TCP. It's not that
at the layer 7, right? You're just removing all those controlling mechanisms and those acknowledgements, and you're putting it in the HTTP level and making it happen there.
So for us, it's not we run on all of our servers. We already run our own congestion control algorithm over TCP. Quick is just that, right? So it's shifting the congestion control to user space instead of being a kernel module. Other than that, it has to do the same things that TCP does, but it's a fresh start at doing things the right way because you don't have to be backwards compatible in the way that TCP
and you have
does.
Context because you know what problem you're trying to solve, because you're closely tied to HTTP, so you're trying to solve the problem that HTTP has rather than being a general purpose like sending packets from A to B.
I don't know that will be true in 5 years, but it's true at the moment. Like I can see quite a lot of applications that like the idea of doing congestion control themselves, pulling the UDP congestion control part out of Quick and using it for their own non-HTTP applications. But at the end of the day, it's just a windowing protocol and has the same restrictions that TCP does. And that would have been an interesting way to start about the latency conversation as well, which is that TCP and Quick don't let you miss data. As long as you can't miss data, and what that I mean is, let's say you go to the CNN homepage, as long as you require that by the time the page loads, you have a C and an N and an N, and all the pixels in every single letter need to be there. There's only so much innovation you can have, as opposed to the let's say latency. So the pure latency argument would be, well, the latency is really good, and we want the CNN to load as fast as possible. And if we're missing 20 or 30 pixels, that's okay, but it will load really fast just with the missing pixels. That's the difference between latency and throughput. And that the throughput, why it matters, is there's a guaranteed delivery aspect to it. And that's why it's hard to predict throughput from latency, because throughput is latency and bandwidth and loss all together. And they don't work. They all need to be working cohesively to deliver all three letters with all the pixels to your browser. And as it relates to Quick, it sounds like it could be doing more awesome stuff, but the reality is just bringing it up a layer where you give more control to the web server and you have more visibility into what's happening. But it's not like Quick can somehow get away with no congestion control, at least not now. It would be interesting if there was a variant of Quick that didn't have congestion control for, let's say, streaming video, and it just let garbled frames happen, or dropped frames, or dropped data inside a frame, and the video client just rendered whatever it got. And if it was missing 10% of the data, then there was 10% of the pixels that were green. Because that's how you can do real time, right? You can either have a network that guarantees delivery, which looks like the old telco system, which everybody's ripped out in favor of IP, which does not guarantee delivery. And if you had the ability to say, no, there's no guaranteed delivery, if there's 10% packet loss, you're not going to see 10% of the movie. That opens up a different world of things that you definitely couldn't do with TCP, that you could do with UDP, because by its nature, it's fire and forget.
We do need to talk about one more thing, because we're already an hour into this. And
okay.
It's very cool. Like, I could do another hour, but I'm not sure our audience can. So, I just want to make a closing note on those choices we have to make, and then we have to bring it down to, like, I want to talk more about micropops and apply it. Like, we always use our Philippines use case. We might want to elaborate why the Philippines and talk about other regions of Asia. But I was in this panel conversation about video and about OTT, and there were like 3 different use cases. There was a sports broadcaster, there was someone who did anime videos, and then there was this third party. And you talk about what do you want in terms of delivery of video. And the guy who did sports broadcasting said like 60 frames a second is really important to us, because like if you're doing sports, like the transition of the ball, like seeing that in a fluent way is super important. Then the other guy said, like, for us, color space, HDR is really important because we're working a lot with colors. So in terms of that, like, that's their priority. And then the other one just said, we want the resolution, we just want the 4K aspect of it. So there's always choices to make, and underlying, like, what you need in terms of technology heavily depends on the use case. And it's very disappointing when you talk to experts and then you pose your problem and they always say, well, it depends. But that's the reality. There's so much nuance on the internet that it depends is the correct answer, as long as you can then justify, like, when you drill down and talk about the use case. Like, especially from that last example, do you use 60 frames a second? Do you go for more pixels, or do you want the color space?
Well, what's interesting, though, is it sounds like it depends is challenging and hard and a bad answer. But if you think of traditional broadcast, that's a way better answer than no, which is what it was. Like, the satellite systems worked the way they worked. The cable systems worked the way they worked. There was no, this channel we're going to let do 60 frames per second, and this channel can do HDR. So it's deceptive in that you want it to be simpler, but the power of delivering all of those over the internet is that you do have choice. And you can find a way where one person can focus on 60 frames per second, somebody can focus on HDR, somebody can focus on 4K in a way that traditional broadcast wouldn't have allowed that, because it's one cable platform or satellite platform or...
And there's always a trade-off. Like, there's never a silver bullet, because then the trade-off would be, well, the internet is not specifically designed for broadcasting. There's just so much going on there. So, like, that guaranteed delivery you were talking about that broadcasting networks do have, well, you don't have that guarantee, whereas the people do have that expectation. Like, with all these streaming services coming to life now, like, I'm from Belgium. Disney Plus released last week or so, where we're at. Yeah. It's a major deal, and people are going to want to have that same experience. Always want to watch it in 4K if you have that 4K service. Or like, I have Netflix at home on a 4K TV. I always want to watch it in 4K, but sometimes there's a little bit of congestion on the network. It's tough to spot, and then you only have 1080p.
See,
well, yeah. Well,
I think of all of this as great, because it just shows where we've come, right? So all you're talking about right now is expectations. And when we started supporting people streaming video on the internet, it was novelty. Didn't matter if it buffered, didn't matter what the frame. It was like, oh my God, I'm watching a video on my computer. Can you believe it?
Yes.
And now we're talking about, well, if it doesn't start in 4K in 2 seconds, then I'm going to switch to another service. that is a huge leap in how far we've come to what we can do over the internet. And the fact that there are expectations that we cannot meet now, I think just proves how good it can be. And so
Can be that good, but we're using technology that wasn't originally designed, and we're seeing like technology, like all the new technology that comes out there comes from these changing expectations, but also the use case that differs. Like all of a sudden, we have to use HTTP, a protocol that wasn't invented for video streaming. We have to do video streaming in an efficient way.
Yeah, but I feel like there's nothing new under the sun. So, satellites that were launched to support TV weren't ready for HD, and it was the wrong technology to delivering HD video to televisions. So they had to really clamp down on the encoding, and they had to use more spectrum than they wanted to originally. Nothing is ever future-proof, and everything at some point is always cobbled onto something that wasn't designed for what it's doing. The electric grid wasn't designed to power electric cars, and it will all fall apart if tomorrow everybody replaced their cars with electric cars. The good news is nobody's doing that.
Really, really good.
The internet would fall over if everybody tomorrow turned off everything they broadcast on their TV and we tried to bolt it onto what we have. So I'm optimistic about it. And not to say that you're pessimistic about it, but I think of the fact that we have expectations. We might not be able to meet them. We're doing it on top of this technology that wasn't built for. I think that sets us up really well for what the future looks like. And as that relates to your micropop question, we're sort of trying to look into the future of, a 5G mobile world with 8K content, with expectations that somebody, when they press play, it's going to play. And what we've started to explore the idea of is doing what we call micropops, which the CDN 1.0, the traditional thought about what CDNs do is, CDNs cache everything, right? You send them a request, they cache them. That's what we do today. But that doesn't scale to if you build the edge, if the edge is to mean 5G in, let's say, we'll get away from the Philippines because we've been talking about the Philippines too much.
Yeah, too much.
Let's say
we
it's
like
Japan.
the people in the Philippines. They're lovely, but we need to, the APAC region is bigger than the Philippines.
So Japan, potentially, you would say, the number of 5G pops in Japan might be 900. And then you say, and we want to deliver 8K content. Well, the math of how much storage it would take to cache all of that doesn't really work. It does if we can go back to charging people $2,000 a megabit for CDN-ish. But other than that, there's no way to just cache ever-growing files in an infinitely growing number of places. So, and at the same time, it's going to be tough to do to deliver a good user experience without building out to those pops. Because, and now I get to use the word, because latency does matter as it relates to the total throughput experience. So fundamentally, CDNs cheat the speed of light. That's what we do. That's how things are faster. We put things physically closer and it allows us to reduce the latency, which gives us more possibilities and ability to deal with packet loss and deal with congestion and things like that. So knowing that there's still a win by putting it physically closer to people, just having the conversation where the conversation is TCP or quick protocol level conversation closer to people, even if the content's not there, can still deliver a huge performance win if we have good connectivity from where the content is to where our micropop is. So if we have a good middle mile network, if you will, to serve the content to the micropop, and we have that micropop really well connected to that user that's 2 or 3 milliseconds away, we can deliver an experience that is exactly what they want when they press play without having to cache the file there. So it gets back to the how good are your misses. We see this micropop type architecture as making us much better at misses. And as we forecast 8K, 5G, all those things, the cache hit ratio or the cache byte ratios have to go down. If right now the customer is at 95% and they're doing 1080p video, necessarily 5 years of growth and they're doing 8K, it's going to be 60%. So how can we improve that new 30% of misses that their clients are going to experience? And the answer is still put things closer, physically closer to people, but the thing doesn't need to be the content. And using the Japan example, if you're there in your hotel room and you're turning on Belgian video streaming, we might say, you know what, we'll just serve the miss. We don't need to keep Belgian soap operas. Not to say you watch soap operas, but I would. Belgian soap operas in our local pop in Osaka. Maybe that's not the most efficient use of space. Maybe that's not the most efficient use of a micro pop or a full pop. But build some of that intelligence about the content, about the client. Is it going to be requested again? Are there 8 people in this hotel from Belgium that are all there for a conference? Maybe we do cache it. But apply some level of either just straight intelligence or machine learning or AI, or pick a buzzword. But use the ability to know more about the content. Put it in the right places, which doesn't always mean as close to the user as possible.
No, because geolocation is not the only factor. It's like the connectivity. Sometimes you can take a longer route, but if it's quicker, well, mission accomplished, because again, it's all about the expectations, not about the technology or the physical aspects. We're just using technology as a means to an end we're just, maybe it's a bit of a strong statement, we're professional cheaters. We want to make believe, right? We built this image of this internet thing magically works and OTT services magically work, but we're just trying to figure out what the next bottleneck would be and anticipate that, figure it out. And then there'll probably be another bottleneck that we have to tackle, and just it doesn't stop. It's like an infinite loop.
Yeah, and so that's I think where our view of where the internet is going and where CDN is going is, we think it is going to get less dense, where interconnectivity and connections happen in all these more edge locations. But as it gets less dense, the connectivity between locations starts to matter more. And that's true whether you're talking, cloud computing or edge computing or CDN. The more we start to terminate connections where the content isn't, or where the compute isn't, or where the API isn't, the more it really starts to matter how intelligently we get from that edge where the connection was terminated to where the thing the user is trying to interact with is located. So I think the first 20 years of CDN were about building an edge. I think I'll borrow your 2080. In the future, I think it's going to be 20% edge and 80% connectivity. And today it's probably 80% edge and 20% connectivity. Like today, it's like, well, if you're in all the edges, your performance is going to be pretty good. 10 years from now.
Well, you clearly have experience with that, and let's use the remaining minutes we have to like apply this to the Asia Pacific region, because you're probably active there as well. There's a lot of lessons that you have learned. We've deliberately used the Philippines, because why? Like, explain to the audience why we did that. Like, why did we go for the Philippines?
It's an interesting market because of the way the terrestrial cables don't go there, and how most connectivity is over subsea cable. But as well, at least for our purposes, most of our content is English speaking. So today, that's a specific market where we have a lot of people consuming our customers' content, and it's challenging to deliver there without having a local presence. You have options with Singapore, Hong Kong, Tokyo, if you think of those as the big quote-unquote connectivity points, but none of them are particularly close. Hong Kong, if you get the right fiber path, subsea would be fastest. It's still 25 milliseconds round trip, which is almost crossing half of Europe, if not all of Europe. So, but it's also a market with really good broadband penetration and high expectations. So it's as true for the Philippines as it is for most countries that aren't emerging markets. In general, broadband speeds and penetration in Asia are better than certainly North America, and sometimes are better than Europe. So you have really well-connected eyeballs with distant peering points for the most part. It's getting better. But it's also an expensive place to be doing business still when it comes to bandwidth. It is not on the same scale to deploy infrastructure as it is in, say, North America and Europe. So a lot of things need to get better for the experience to be good. But at the same time, there's nothing but opportunity. So we're taking what we've learned in North America and Europe, South America, and trying to apply those playbooks to not just, Philippines is actually a pretty easy solve, but there's a lot of Southeast Asia that's harder. But at the end of the day, it's how do we continue to build that edge, what today is the CDN edge, what in the future might be the 5G edge, in places that don't have the data center density today. You can't just go into 15 data centers in the Philippines that are well connected and well peered. They don't exist. So hopefully the idea of micropops and 5G edges allow us to have some penetration in those places where there's not a traditional sort of carrier neutral data center environment. But it's early, and I don't know. The things we think today might be wrong.
Like, do you have like a micropop in there in the Philippines, or are you considering it, or are these things that are tailor made for specific clients of a certain scale and a certain location?
No, there can be that too. We do have 2 micropops going into the Philippines this quarter, with 2 different carriers because there's no real good peering between them. And then otherwise, there's a new exchange point going up in Japan on the very west coast that we're going to deploy a micropop into. We're looking at doing one in Vietnam this quarter. So it's part of our strategy. I think it's going to be how we scale in the region. We're going to continue to add a few of our traditional larger pops, but micropops allow us to be much more nimble, work with just an individual carrier. So it's almost like the embedded Facebook caches or Netflix Open Connect. Yeah. So you can get inside a carrier's network way easier if our CapEx to do it is 10K versus 400K. It just allows us to deliver a better experience to more distinct network edges than if we continued to think of it as, okay, how do we build something where we could cache all the things all the time?
But then again, it depends on where the demand is. Is the demand on the client end, or on like one of your clients, or actually the end user who is consuming this? Like if you have some of your CacheFly clients who really want to be there, well, then it makes sense to build that out. But just hoping for, maybe your metrics show that for specific kinds of content that didn't come out of an inquiry that said build us a micropop in the Philippines, you probably do measurements to figure that out as well. Like, oh, all of a sudden we see all this traffic coming from the Philippines. We don't have the most efficient route. It might make sense to put a micropop there to, again, drive this back to experience, to improve the quality of experience.
Yeah, and I think that's true. Like the drivers, obviously customer demand is a big one. We do look at just inbound inquiries, as in, like, lots of providers reach out to us and say, what would it take for you to put a pop in our network? Those are usually a little harder to wrangle because you're trying to look at all the variables, and we don't really love outsourcing network ops. So the less carrier neutral it looks, the less options we have for controlling the routing. It's a little more dicey. So we tend to look at those inbound carrier inquiries mostly as, okay, if it only went to your eyeballs and only on your network, what would that look like? But the last one that plays into it now a lot more today, and will be a lot more next year, is multi-CDN, which is you can actually go not just, well, are things slow, but now you can say, well, if it was faster, would we get more revenue? And not in the sense of going to a potential customer and saying, hey, if we built a pop here, is that enough for us to win your business? But actually, like, you turn it on tomorrow, and 2 days from now, you have a ton more traffic because multi-CDN has switched it over. So we recently did a test build in Moscow that there's a couple of dominant players that we compete with in multi-CDN who have decent presence in Russia. And we went, okay, this won't go very well, but we'll try it. Customers asking, to your point, let's see what happens. And we turned it on and then, oh, that's a lot of traffic. Okay, so we called the partner. We said, hey, can you double the amount of servers we have for this test? And they said, okay. And then a week later, the traffic doubled. And we went, okay, can you double the number of servers again? And they went, okay. And then the traffic doubled. So, we have, for a specific customer, 65 days ago, we weren't doing almost any traffic to Russia for them. Definitely none inside Russia because we didn't have a presence. And 2 months later, I think it's 30% of their traffic they bring to us.
So all of a sudden that micro pop suddenly became an actual point of presence there in Moscow, in Russia.
Yeah, and truthfully, it's just a bigger micro pop. We still haven't, because it happened so quickly, we haven't had time to backfill it into a more substantial presence. But we also, to really bring the analogy full circle, we also might not build it into a full pop and just leave it the way it is, because on our roadmap anyway was building into Stockholm this year. And Stockholm is a really good place to feed those caches, those micro pop caches in Russia. So we might not end up even fully popping it. We might just beef up Stockholm a little more. So
what you're basically saying comes back to how good your misses are. So you probably have a multi-tiered environment where it's perfectly fine to have a miss on the actual edge, as long as what is considered to be the origin is yet another layer of caching that in this case it's Stockholm.
Exactly. And today that's it's unfortunate that we weren't able to serve it locally, but that's okay because it's going to perform really well. Our sort of future-looking state with the 5G and the 8K and what we've been talking about is not going to be oh, it's unfortunate. It's oh, that worked exactly as planned. Of course it was a miss. We weren't expecting it ever to be a hit, and this was our plan to serve it, and our plan worked. Great.
Yeah, that's what our reference architecture looks like, because in most cases we're offering multi-tiered as well, where you have a storage component and where you have an edge component, where the edge component is more tuned at what's hot, the hot blocks, also some more logic, because it's not all about video, it's not all about static data. Sometimes you just want to host websites and do some, what we call, air quotes, edge compute, where some basic level of compute happens, where decisions are made, where termination is done, like authentication, termination, all that kind of stuff, where dynamic data was fetched from a third party, be it an API, be it a database. So that happens on that outer tier, but just a lot of the storage happened on the tier below. And of course you're going to have misses, but as you mentioned, if these misses are tolerable and if the throughput between whatever's on the edge and whatever's on the secondary tier is fine, that's good, as long as you don't hit the original origin, because that's the reason why you had CDN altogether, because these are a bit prone to stability issues, prone to latency, whatever.
Yeah, and we've built a product called SOS that is meant to solve that. So the first CDN approach to that was we'll cache everything everywhere. The second CDN approach was oh, it looks like we can't do that anymore. We'll do origin shielding, so we'll send it all through one region that'll do its best job to cache everything everywhere. What we have with SOS is dedicated shield storage basically for customers. So if you say, hey, we need 100 gigabytes of CDN storage capacity, that will be dedicated to you and not a shared resource where one of your competitors who's having a great day can kick your objects out of cache. Yeah. And one of the interesting things we've found in talking to people about this, obviously it's a big win for people who are doing video and have their origin on object storage where they have these big bandwidth bills. We think of it as the S3 bill reducer product. But what we're finding more and more of is two things. Number one, the small, really long tail only customers get a huge advantage from it. So the quintessential example is an e-commerce store with 200,000 product images. They're getting, somebody came to us, they were getting a 30% cache rate ratio on another CDN. And just because they're very infrequently accessed pages, but their average ticket size in their catalog, it was a $10,000 item. So they really wanted that experience when you got to that page to be really good. So giving them a guaranteed quality of service where that was never coming back to origin was a big win for them. But the other perspective that we hadn't really thought that much of internally is cost in the form of compute and or time to generate the objects, and how much to you have of that infrastructure you have to keep available in case you get a surge of cache misses. So by giving people dedicated cache tiers that said, this is your space, nobody's going to evict you from it. We had a customer who reduced their cloud compute bill by more than half, which was like $14,000 a month, just because they knew nothing was going to be evicted from cache. So they knew what the request rate was going to be that they needed to solve for. They were never going to get
That's exactly our use case, because that's why we do what we do, right? We're not a CDN company, of course. That's your specialty. We just provide the software to get the job done. And a lot of people want that control. They don't want to be on a shared service. They want to be on a dedicated service. Now, of course, like in your case, you can provide those dedicated services based on the software we provide. But for some companies, it's all about control. Like pricing, of course, matters. But if you have the proper control in the long run, your cost will be a lot more predictable. But people just want to have their dedicated space. They want to have, like you use a ton of our vMods just for this, not for the sake of it, but because there's functionality in there that you can tune. It's not like, hey, here's a couple of commercial features that we offer. No, you want specific things that, like, can you elaborate on some of the vMods that you're using? Now, for the people who don't know this, a vMod is a Varnish module. It is a module written in C, and that exposes an API that is written in, or that exposes itself to VCL, which is short for the Varnish configuration language. And VCL is the programming language that we offer. So basically, you don't put in a couple of XML files or INI files or conf files. No, you actually have a full-blown DSL, domain-specific language in which you can program the behavior of the cache. And because the language has restrictions, of course, there's only so much you can do. We have an ecosystem of vMods. And if you take our enterprise version, we ship a lot of those vMods by default. And that's exactly what Matt is using. So Matt, what are a couple of ones that you're really relying on?
So we rely heavily on the go-to vMod. So years ago, our VCL looked like 20 to 30,000 lines of just defining our customers' origin servers.
And that's because in Varnish, like typical Varnish, especially the open source version, you have to define all the backends individually, and you have to use all the backends that you define. So that's like a constant update job of making sure the inventory is correct. And if you're operating at a very large scale like yourself, this becomes a bit of a pain in the ass. Whereas GoTo is just a module that does this on the fly.
Yes, and it gives us flexibility that we didn't have before. So we can do so much more, even just from inbound headers that our other tiers of caches give us. So GoTo is a big one. YKey is another big one.
Well, YKey is very specific to MSE. We're very bad, like deliberately we make fun of it, bad at naming things, because we invented XKey, and the next version is YKey, of course, because alphabetically that's next. But YKey was invented because there were specific limitations in XKey that didn't work well with MSE. And since you rely on MSE that much, YKey was the next evolution to make sure that instead of just focusing on URLs, because like when you talk about cache invalidation, which is like, we've been talking about trying to cache as much as possible or talking about good misses, but sometimes you really want to force something out of the cache because you don't want to cache it too long. That's one of my quotes. My quote is, there's only one thing worse than not caching enough, and that's caching too much. And that definitely applies. Like when you have a breaking news website and there's breaking news, but the page is cached and you're not serving that news, well, you're at a competitive disadvantage. So you want to, like a lot of systems have that, especially there's tons of examples, especially in the open source with Magento and Drupal and WordPress and what have you, where they link the invalidation mechanism to the CMS. So as soon as an article is published, a hook is being called that sends off a request to Varnish to specifically invalidate that piece of the content. Now the problem is when you have very complex content types, where it's really hard to trace back a content block to one or multiple URLs, you just give up. You don't do it anymore, and you start tagging content along. So an object gets a bunch of tags, and instead of knowing the URLs, if you invalidate a tag, you could like have a million objects invalidated at the same time. And that's what X key does, and that's what the improved version Y key does.
Yeah.
So
And then
far,
the
the
last one
reference.
I think that we use in an interesting way is we use the VS Throttle module. And one of the ways we're using it today, so the intent of the module was to, I believe, limit the number of concurrent connections a client could make. But we've used it slightly differently, and it's actually today part of the initial algorithm in the micropop architecture. So we use VS Throttle to figure out if we should cache a file or not. So we use that as, instead of having to reinvent the wheel, which we think much of the VMods save us from having to solve a problem that seems that seems like it's a primitive you would expect from a programming language, and it brings some of those right into VCL for us. So that was one where we could not have to keep track of all the requests ourselves and all that sort of thing.
But because it's written in C, it's just like a matter of you can implement anything. Like if there's a good enough use case, we'll build it. When there's a good enough feature request, like the next version will just contain that feature.
Yeah, and then the last one that we couldn't run the CDN without is KV Store. That's really
an interesting one. That's an interesting one because that's nothing more than a key value store in memory, accessible from VCL.
Yeah, and that's the power. It's so simple, and that's why it's powerful. And it's something that would have saved us hundreds, if not thousands, of programming hours to make one that's scalable, functional, doesn't lock when it's accessed by hundreds of thousands of threads, and it opens up the power of VCL quite a lot when you have something like KV Store that allows you to play with data that isn't in the HTTP request, and that was really the missing part that we felt KV Store fixed for us. Was it allowed us to have sideband data, if you will, where we could import data that didn't have to come in via HTTP request, use it to build a response, and it kind of makes the whole thing go on our side. So without those 4 VMods, for sure. We also use Fast 304, so we're up to 5. But we would have to re-architect in a much less good way if we didn't have all of that at our disposal.
Yeah, and if we extrapolate that from, because it's easy to say, hey, yeah, these are features that Varnish offers, but it just goes back to doing more on the edge. And like as an evangelist, I come across a lot of developers, and I try to educate them on, look, doing it at the origin is slow, and the trade-off would be, oh, this would be a cache miss because there's personalized data in there or computing happening. You can't cache it. Now all of a sudden you simplify whatever you're delivering, you're storing it in cache, and then that placeholder perhaps where personalized data would be in, you just do that on the edge, and then that's a big one. Like if you can leverage those things that weren't cacheable all of a sudden become cacheable. And that's a big one in terms of performance.
Yeah, and as you think about that use case I mentioned for people who, not necessarily big content, it's not necessarily a lot of it, but it's expensive to generate in terms of compute or the time. Like we have some customers who have objects that it might take them 8 seconds to transcode the video or splice together audio. But then once you have a way to cache it correctly, you're saving 8 seconds every time somebody makes a request for that object, plus the compute time to build it. So the more power that you have in your Varnish instance to move things to cache in a way that, let's say, even on a commercial CDN, you wouldn't have that power in the rules. Our customers who have Varnish as the origin that we pull from tend to have the best looking graphs from our standpoint of how long did it take us to pull the object, because they've put the time in to make sure that the miss experience, when it's a miss from the CDN, is as good as it can be. And at the end of the day, that's like I say, might not be today, but in the future, that's going to be the role of what caches are, is to make the miss experience better.
Yeah, and like HTTP already has those mechanisms in place, like doing conditional requests using e-tags, using if none match. It's just whenever your cache has to miss because it has expired or it might have been there altogether, you can make it easier. There's mechanisms in there to just revalidate. And if the content remains the same, so be it.
Sure.
And if it's not, then you just architect for that. Now,
Yeah.
last topic of the day. We're focusing at, we talked about a lot of random stuff, but I want to end it with something APAC alike, and that's China. Are you working or operating in China, and what are some of the challenges there?
Sure. So we have CDN in China today. Our sort of specialty, for lack of a better word, is truthfully bringing businesses that aren't in China today in. So we work with customers who typically are based in North America, Europe, or elsewhere in Asia. They want to get into the China market, or they have a specific customer or client need. And what's interesting is today the bar is still very low. It's not, hey, I need it to, I need at least 10 megabits per second of throughput, or I need it. The people come to us with like, I need it to work. Right now,
I
it's
need
broken.
to get behind that firewall.
Yeah, like anytime I go through the firewall, it's broken. It's not like, oh, the performance could be better. Like we have one customer who's a global ad. This is like a good example, but a bad example. So they're a global ad tech firm, and they deliver trillions of ads a month. Don't want to deliver ads inside China for compliance reasons, but they have a large ad buyer inside China. And this company spends $20 million a month on infrastructure globally, probably. And they had an ad buyer in China who couldn't access their reporting portal. Forget delivering the ads and delivering them in 5 milliseconds or whatever. This was somebody who was spending $1 million a month in buying ads and couldn't buy more, couldn't log into the portal, couldn't put in a username and password, load a report, say, I would like to buy more or I would like to buy less. And that's like the bar that we're operating at if you're outside the firewall is it might not work, period. Our advantage, we think, is we have a good partner inside China that we use to help people get ICP licenses if they don't already have an ICP. We run infrastructure in Beijing and Shanghai today. They're interconnected with fiber, goes back to the middle mile. And then from there, we have connectivity from both cities through the firewall, so that doesn't get slowed down by the firewall, to Hong Kong. And then we ingest from our customers' origins in Hong Kong, take it through the firewall on the private line, and then serve it locally from one of those two POPs. And the feedback we get all the time from people is basically, oh my God, which seems simple, but it's challenging. I can tell you we underestimated when we deployed how challenging it would be to just do that, right? It seemed pretty straightforward. Build a couple POPs, build a couple of private circuits.
Yeah, you have the playbook there, like past experience.
Yeah, and it is its own unique marketplace. So our value there that we think we have today is just helping people deploy into the market. If you're already a Chinese entity and you already have all your servers in China and you're already looking, your CDN today is only in 22 cities and you're looking for a CDN that's in 80 cities, that's not what we're doing in China today. There's companies that are better at that. But we think we can do a very good job helping people get into the market without having to actually deploy everything inside the firewall. So the way we think of it is we help people get in and out of the firewall without having to jump all the way over.
So thank you, Matt. And thank you to everyone who took the time to be here with us. We'll do more webinars like this. But with that being said, thank you, everybody, and have a pleasant day. Matt, you have a nice day too.
Thanks, you too. Cheers.